with all of these reactions, you need to decide what the acids and the bases are, and you do that by deciding what are the proton donors and what are the proton acceptors. So, for example, in the first one, this water is, if you take a look at it on, that's the reactants, here are your products. If I take a look at it on the product side, the water is short of a hydrogen. That means that this water donated a hydrogen to that ammonia over there. And so let's take a look at what happens. The ammonia has gained a hydrogen. The water has lost a hydrogen. So let's try and label this. Proton donors are acids, and so that's acid number 1. Proton acceptors are bases. It's not base number 1, it's base number 2. It doesn't matter which one you label 1 and 2, but you need to get the connections right. So once the water has lost its proton, it turns into the hydroxide ion. So that's base 1. That's your first acid-base pair. Now, if I take a look at base 2 has accepted a proton and becomes acid 2. That is my second acid-base pair. Now, things to notice are that the pairs are always one reactant and one product away. You don't say this is an acid-base pair or that is an acid-base pair. It's the link across the double arrow that is going to show you your acid-base pair. Now they want 2 acids, so if we're looking for 2 acids, we're going to say I'd like the ammonium ion and the water are my 2 acids in that one. Identify the Bronsted-Lowry acids in the following reaction. Again, I just need to go through my process. So I can see over here that this nitrous acid is going to lose a hydrogen and then become NO2. So this hydrogen goes to there. So what have we got? We've got a proton donor. Once it's donated its proton, it becomes that proton acceptor if you were to go in the opposite direction. Then on this side, you've got, this is a proton acceptor. And once it has accepted a proton, it turns into that acid over there. So what are my acids in this case? There's an acid and there is an acid. Identify 2 bases in the next one. So again, I look, where have I got a proton moving? The proton moves from here to there. So I have got a proton donor and a proton. Once it's donated its proton, it becomes that base over there. You've then got a proton acceptor. Once it has accepted its proton, it becomes that acid over there. So if I'm looking for 2 bases now, I'm going to say there's one base and there's another base. Again, let's look for 2 bases. I'm going to see what happens to the hydrogen, and I can see that a hydrogen goes from here to there in order to make the product. So here's my movement of the hydrogen. Here is a proton donor. Once it has donated that proton, it turns into that base over there. Here's my proton acceptor, base 2. I'm sorry, I'm making a mistake here. I've done it twice actually. That's 1, because your acid-base pair, that's 1. This is 2, and this is acid 2. So my acid-base pairs are going to be from there to there, and from there to there. But this asked me for my bases, so I'm going to say there is a base, and there is a base. Now we want the acid-base pairs. So I can again see that this hydrogen is donated to there. So we are going to say this is a acid, and once it has donated its proton, it becomes a base. That's acid-base pair 1. Acid-base pair 2, this is a proton acceptor, and once it has accepted that proton, it turns into that acid. So this could have been one of your acid-base pairs, and this could have been one of your acid-base pairs. Moving on, I can see that this hydrogen is donated to that water over there. So there is a proton donor, acid, which turns into this base. and then we have got a base proton acceptor, which turns into this acid over here. Again, look at this. I will always have a 1 and a 1. I will always have a 2 and a 2 on either side of my equation. What are my acid-base pairs? My one acid-base pair is over there. My other acid-base pair is over here. Identify another acid-base pair in this reaction. So I can see that my hydrogen over here is donated across. So this hydrogen gets donated. So we have an acid that donates. Once it's donated, it becomes this base. We have a base that accepts, and once it has accepted, it becomes this acid. And so here's my one acid-base pair, and here's my other acid-base pair. There is no rule that says it's the two middle ones and the two side ones. That's just a coincidence over here. It could be any of them. I can write the reactants and products in any order and the reactants and products in any order over there.